Hey, good morning, scholars. I am dropping in to make a quick video to explain the difference between area and perimeter and volume. It's one really big difference. And I want to make sure we understand the difference so that we know what to use, which formula to use when we see a problem, whether it's a volume problem or whether it's a perimeter and area problem. Usually the problem will tell us you need to find volume or you need to find area and perimeter. But it's always important to understand when we use them and why. So for the last few days, we have been talking about perimeter and area. And everything we have been measuring has been flat, right? We were measuring just 2D shapes. What does the D stand for in a 2D shape? Well, the D stands for dimension. It's two-dimensional, which means it is flat. Remember those books that y'all probably read in maybe first and second grade called Flat Stanley? Flat Stanley is two-dimensional. So pieces of paper are two-dimensional. All they have is one dimension and the other, right? They aren't thick, they're flat. What else is two-dimensional? Well, I'm just looking around my room. My clipboard is two-dimensional. It's flat, right? What else is two-dimensional? Really everything I'm looking at is kind of paper. That's mostly what are two-dimensional, what is a good thing? Well, we can think, oh, what's an example of something that's two-dimensional? Oh, paper. Paper is two-dimensional. Well, that is area and perimeter measures those shapes, those flat 2D shapes. Okay, but volume is different. Volume measures shapes that are 3D, three-dimensional. Well, what is three-dimensional? Well, a box. My box here is three-dimensional. It's a really dirty box because it sits at the bottom of my desk, okay? It's three-dimensional because it's not only has a length, right, and a width, but it also is deep. So I have this measurement I can also measure. And then what volume actually is how we measure it is we think, okay, I'm going to take some cubes and fit them all inside this box and stack them all up until the whole box is filled. And volume is how many of the cubes fit inside the box. That's what volume is. So if I said it had a volume of 200 cubic units, that means that 200 cubes fit in here. And that would be the volume. So volume is measured by little cubes. This is my cube. A cube has the exact same measurement on each side. So I think this is a cubic inch, which means I have an inch here, I have an inch going up, and I have an inch going back, okay? And so we use the cubes, everything is the same dimension, the 1 inch, and we fill it up with the, fill up the shape that we're measuring, and that's volume. Now, we don't actually physically do that. We don't actually physically put cubes in our 3D objects and measure, but that's what you are doing when you are measuring volume. You're just doing it mathematically, not physically. However, today we are going to be using some online manipulatives where you will be physically online putting cubes in a box to help you figure out the volume, okay? Well, in a moment, you're going to be watching a couple videos about finding volume using cubic units, so counting the cubes to figure out volume. And then tomorrow, we're going to be using our formula because that's basically the two ways you find volume. You can either count the cubes, and I guess you could, anyone can just put a bunch of cubes in the box and fill it up and count the cubes, or you're going to use the formula, okay?